All right, everyone, and welcome to our third video cast for our second unit. And today we're going to be talking about psychology and scientific research, right? And how we use research as psychologists to find out information about humans. So, a couple of things before we get started. I want you to tell me if these three statements are true or false. So, pause if you need to before we go on, right? Guess what? They're all false. Every single one is false. Yet, for some reason, we've all heard this before. We've all heard that people during the full moon people act crazy, or that kids eat razor blades or needles in their candy from Halloween. People poison them. But that's actually not true. It doesn't happen very often. So how does this bad research and this bad information get out into society? Because some people don't take time and effort in conducting research for psychology and give out bad information. And that's not going to be you. So, in psychology, how do we use the scientific method and how do we research things in order to get proper information about humans? Okay, why do we even need to do research? Isn't psychology just common sense? I mean, duh. So here's the deal, right? Common sense has limits. First of all, you are subject to something called the hindsight bias, which basically means that you tend to believe something after I tell you that it's true. You tend to think, oh yeah, I knew that. So for example, if I told you that the sky is blue, you'd be like, oh yeah, I knew that. But you didn't really know that before I told you. Now that's a bad example, but with anything is that after I tell you something is true, you tend to think, oh yeah, I knew that already. But you actually didn't know that. It's called the I knew it all along phenomenon. Okay? Another reason why our common sense sucks is confirmation bias. So as humans, we tend to look for information that confirms things we already think are true. So for example, if I think that crazy stuff happens on the full moon, all I do then is look for all the crazy things that happen on the full moon. And I ignore all the crazy things that happen every other day when there isn't a full moon. So I'm looking for information that confirms what I already think is true. And the last one is overconfidence. And I've already talked about this a lot. We think we're a lot smarter and we know a lot more than we do. So you don't actually know that much. All right, scientific method. So for a lot of this is going to be like a repeat. You know, we've been through science. We know this. So I'm going to go kind of quickly. Stop if you need to. Pause. Replay back if you need a refresher from Bio 101. Okay, 4 goals of psychology. We talked about them last time. Describe, explain, predict, influence. All right, so we use the scientific method in order to get good evidence that we need to use to describe and explain human behavior, right? Evidence is based on observation, measurement, and experimentation. We can't describe and explain human behavior just out of nowhere. We use scientific method and research to actually describe it and explain it accurately. And that way we can influence it properly and make good, positive changes. All right, so what's the first thing you do when you're doing the scientific method? You come up with a hypothesis that you can test, okay? Hypothesis is a statement of 2 variables. So in this example, it's if you are a girl, then you're more likely to be bullied. That's a hypothesis. It's an if-then statement. If you are a girl, then you're more likely to be a victim of bullying, okay? So what are the 2 variables, right? In this, they are gender and bullying. Okay, those are the two variables that we're testing. And we think that if you are a girl, you're more likely to be a victim of bullying. That's our hypothesis or our guess. Okay, once we come with our hypothesis and we have our variables, we have to define the variables, okay? I have to say what gender and bullying mean. I know this sounds ridiculous, but guess what? Maybe my version of bullying is different than your version of bullying. And maybe I think bullying is name-calling and you think it's punching. So unless I define bullying properly, it's going to be very difficult in order for anyone to ever recreate my experiment. I have to define bullying so that when people look at my research, they know exactly what I was talking about. Obviously gender is a little easier to define, but if there was another thing, like I defined smiling, or I had to define attractiveness, whatever you're studying, you have to define. An example of this might be bullying in my experiment would be verbal or physical insults to either in person or on the internet that occur more than once. So if I say, hey, yo, Judith, you smell, and then I walk away, and I only do it one time, that's not bullying. But say I'm like, Judith, you smell, and the next time I'm like, Judith, pee, you smelly pants, right? Then it's more than once, and I'm bullying. And if I Facebook her, and I'm like, Judith smells, blah, 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 on my Facebook page, blah, 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 and I tweet it out there, that still counts, right? So now anyone who looks at my study will know, oh, all right, bullying is this. That's what Ms. Schaefer was looking for in her experiment. All right, so continuing, right? So we have a little visual here for you, right? You come up with a theory, you develop a hypothesis, and then you research and test your hypothesis. All right. You got to design the study and collect the methods. So in our study, right, we have two ways of either doing a study. You can do a descriptive study or an experimental study. A descriptive study is just to see if things are related in any way, okay? It's any relationship. An experimental study is actually used to find cause and effect. So, for example, a descriptive study would tell me if gender and bullying were related, where an experimental study would tell me that gender was causing bullying, okay, not just a relationship, okay? So, when we look at descriptive research, there's naturalistic observations, case studies, surveys, longitudinal studies, cross-sectional studies, correlational studies, and then with experiments, right, experimental research, you have experiments. So today we're going to focus on the descriptive side of things. So, first research method that you can use is to observe someone in their own environment, naturalistic observation. Okay, someone who's very famous for this is Jane Goodall. She spent lots of years observing chimps in their own environment. She literally went into the jungle and sat there and observed the chimps and took notes on them and what they were doing, right? And she found out if certain things were going on in their world. So if I'm studying bullying, I might naturalistically observe. I might go into the cafeteria and watch bullying, okay? I'm observing it. By observing it, I'm not going to be able to tell if something is causing something, but I can tell if something is related. Like every time someone bullies, I see this going on, there's a relationship there. And hopefully in the cafeteria, no one's going to know I'm there. The goal is to observe them in their own environment without them realizing you're there, because it's natural. Next is case study, right? A case study is an intensive, in-depth investigation of one people or a small group of people to hopefully find out things about a lot of people. So if I wanted to study bullying, maybe I would study bullying in Columbine, and I would really look at how the students who committed the crimes at Columbine, how bullying and their gender mattered, right? And then I would try to apply that to everyone. Okay, next one. I would do surveys, right? And another type of research is surveys. So I give out questionnaires. Maybe I give out a questionnaire to the entire student body of Mundelein, and I ask them questions about bullying and if they're a boy or a girl and how many times a week they're bullied, whatever. And then I, compile all the data I get from these surveys, and I come up with some conclusions about bullying and gender, okay? So I give out I give out questionnaires in order to get the opinions or characteristics of certain people based on if they what they tell me in their results. All right, a correlational study is the last kind of descriptive method we're going to talk about, okay? A correlational study actually looks at the strength of how things are related. So, for example, with naturalistic observation, with a case study, with surveys, I might try to find if things are related. So I might look at the number of girls that say that they're bullied and what time of day they're bullied or whatever, and I'm going to look at the relationship between things. But with a correlation, I'm actually looking at the strength of the relationship. So how strongly is gender related to bullying? Or how strongly is poverty in bullying? Or time of day in bullying? Or whatever in bullying? And I'm looking at if I can use one to predict the other. If this happens, then this might happen. Correlation does not equal causation. Correlation does not equal causation. In other words, just because two things are correlated does not mean that one causes the other. Here's some really good examples. They found that when attendance increases, grades increase. And when attendance decreases, grades decrease, right? So attendance and grades are related, right? They are correlated. There's definitely a strong relationship. But does that mean that attendance actually causes good grades? No. It can predict it, but it can't cause it. A lot of other things probably cause grades just besides attendance. Here's an even sillier example, okay? They found that as ice cream consumption increased, murders increased. And as ice cream consumption decreases, murders decrease. So does this mean that ice cream consumption causes murders? No. Ice cream consumption can predict murder only to a certain degree, that maybe as more ice cream is getting eaten, more murders are being happened. But ice cream eating does not cause murders. You know what's similar about both of them? They both happen in the summertime, right? So it's not that one causes the other. It's just that they are related and one can predict the other. Okay. Another example is Frosted Flakes. They found that people who ate Frosted Flakes as a child had half the chance of developing cancer as those who didn't. So does that mean Frosted Flakes prevent cancer? No. They're just related. There's a relationship between Frosted Flakes and cancer. And guess what? There's a third part of this. People who ate Frosted Flakes probably ate breakfast, and if they ate breakfast, they were healthier, and if you're healthier, you're going to have less chance of cancer. So a correlation is not a causation. It's just that one predicts the other. Again, correlation does not equal causation, right? And there's a lot of times that we believe that there are a relationship between two things, then when there's really not, okay? So people are like, oh, once you adopt, all of a sudden, then like people who adopt who can't get pregnant, all of a sudden they get pregnant, and they think that there's a relationship between the two of those things. Or, it's cold outside and you get a cold, so like the weather causes colds. No, okay? The human mind, like I said, we like patterns. We like cause and effect. We like to find and we like to seek patterns and random things. So random things that seem related are called illusory correlations. They're not actually related. So when you do a correlation, you get a correlation coefficient. The correlation coefficient has two parts. It either has a positive or a negative, and this tells you the relationship of the correlation. So is it a positive or is it a negative in terms of on a graph, and I'll show you in a second. Then the number indicates the strength. The closer to 1, the stronger the relationship. The farther away from 1, the weaker the relationship. Okay, so when you do a correlation, it looks like this. You do a scatter plot. If it's a perfect correlation, all the plot points are in line. If not, they're very far apart. So this is a correlation between grades and beers drank in college, right? The correlational coefficient is negative, right? You see the negative sign. So this means that as the number of beers go up, the grades go down. They are negatively or inversely related. As one goes up, the other goes down. If it was a positive relationship, they would both go up or both go down together. So, but it's negative, it means grades go up, drinking goes down. Or grades go down, drinking goes up, right? And the strength of the relationship is 0.74, which is pretty close to 0.1. So it's a pretty strong relationship. Don't worry, you will never have to figure out this number on your own. I will always give it to you on a test. There's a formula to figure out, but it's kind of hard and complicated. All right, guys. That's all for now, AP Psychos. And remember, psychology is flippin' awesome.